Now, I, Ishan Minhas, am going to start our project LoRaWAN Gateway Architecture Setup for the aquaculture monitoring. This project has been divided into 5 teams. First team is handling the calibration of sensors to measure the oxygen level, pH balance, and other nutrients. The second team is collecting the data through nodes and passing it through. The third team is catching that data and establishing a gateway and also sending it to the cloud. The fourth team is responsible for data manipulation in the cloud and sending it to the fifth and the final team. The final team has taken over the task of building an application and visualizing and manipulating the data with graphs and other algorithms. We are the third team, and we are responsible for the LoRaWAN gateway architecture. Now, I would like to call upon Govind Sharma to elaborate the objectives of our team in the whole project.
The main objective of our project was installation of the LoRaWAN gateway and creating a whole network of the LoRaWAN sensor nodes sending data to a single LoRaWAN gateway. And we carried this out in a centralized approach. Multiple sensor nodes as well as single gateway are installed that allow long-range wireless data transmission and low-powered battery operation. From the gateway, we upload the data to the cloud where the analysis of the data is done. The person can monitor data on the mobile through apps. We carried out evaluations in detection of transmission range, battery runtime, and sensor data accuracy. From the gateway, we upload the data to the cloud where the analysis of the data is done, and the person can monitor data on the mobile through apps. We used various sensors for this purpose, like Pygate 8 channel LoRa gateway, PyCom 5Pi module, PyCom LowPi module, antenna, etc. Now Pranav will illustrate the specification of the hardware devices.
Create a gateway, we used a hardware called Pygate board. Pygate is an 8-channel LoRaWAN gateway which consists of a 28 sockets to connect one of the PyCom modules such as LowPi 4 and GPi and connect any other PyCom devices for a decentralized IoT network. In this project, we used LowPi. LowPi is a microcontroller developed by Picom that has LoRa, Wi-Fi, Bluetooth modules integrated in it. An antenna can be connected to Pygate to catch the radio frequency. The term LoRa refers to long range. It is a spread spectrum modulation technique derived from chip spread spectrum technology. Now, Gurkirat will illustrate the working of Pygate.
Now coming to the implementation part of the project. First of all, I will connect the device with the laptop. So here's the device manager. Our device is connected on COM4, and in the Atom, our device is shown as connected. So first of all, I will run this code to connect it to Wi-Fi. So our Wi-Fi connected successfully. Here are the IPs to which it is connected. Now coming to the main implementation of our project. So first of all, we have to register the gateway to the Things network. For registering the Things network, we have to go to the gateways and we have to register our gateway here, for which we need the gateway EUI. So I have already registered it. So I am going to run the code again for getting the gateway EUI. So this is our gateway EUI, which I have filled here. So this is your gateway. From this, we have to download the global.config file. So we have to run the two files. One is main.py. Here's our code, and second one is configuration file. This is the configuration file. This is the network to which is connected, and this is the gateway EUI. So now running the main file. So our project is uploaded on the board, and it is running on loop now again and again. So now coming to the Things network. So here's our console. So if any node will send the data, we will get it here. So we have done the receiving part, and for sending the data, the next group can get the data from here, because the thing stack is a network and cloud.
As we know, range is very important parameter for checking the network connectivity. For that, we will be considering various parameters like link budget, path loss, etc. We can also use device called the field test device to test the network strength. It can be used to measure the signal strength and is also LoRaWAN certified. It also has a feature that it has a geolocation of measurement points. For testing the range, we have two types of testing, which are user-based range testing and device-based connection test. In user-based range testing, a radio signal is selected at a point at a specific time. It provides rough coverage of a radio network. If there are enough measurement points, every LoRa device is configured to send data packets regularly in short interval. In device-based connection test, we plan to install the device at a certain location where we are mainly interested in the coverage or radio quality of the area under all circumstances. Every LoRa device is configured to send data regularly at shortest possible intervals. Various test data is shown in the slides and a graph is plotted about the RSSI and the range. So now we can conclude from this project that we have created a gateway for receiving data from the nodes and uploading the data to the cloud. Also, the gateway is connected to the network for reliable and anytime access to the data. Also, a graph of RSSI versus distance is plotted and the measures to increase the range is mentioned below. Thank you.